Thank you very much for attending my talk. So you're here hopefully to learn about some of the advanced functionality that Postgres supports when it comes to standard SQL. So here we go. If the clicker works. Maybe it will not. It was. I'm unplugging it in order to... Oh man, Frost. See what you did.
I didn't do it.
You did. I'm going to exit out of this and restart.
Yeah, exit and come back in.
I unplugged it though.
Oh, why?
Well, because I figured if it
just
shut off in the middle.
I thought like it.
This is what happens when you test it and then don't touch it for a few minutes. It stops working. It worked great 5 minutes ago. There we go. Thank you. So here we go again. Yes, round 2. So depending on the level that you are of SQL and how much familiarity you have, what you consider basic SQL can vary vastly. So a lot of times I conduct interviews and we start interviewing people and we say, what's the basic structure of a select statement? And they go, oh, well, you select something from a table where some condition, and then maybe you order it. Okay, so that's a start. Then maybe you get to the point where you know that, oh, you can join multiple tables together and then perform some other calculations. Okay? Then, as you get farther in your career, you say, oh, I can also have various aggregates, and I can do a group by, and maybe I even know what a having clause is. But in reality, if you look at the actual documentation, the syntax for a select statement is quite complex. So you have all of these various components, most of which are optional, and then you have some more components, and then you have some more. So throughout this talk, we're going to review a handful of these, but obviously not all of them, because you probably don't want to listen to me talk for 5 hours. So the first thing we're going to start with is values. Typically, this is used in an insert statement, but really it can be used to create an on-the-fly table or anything you want. So your syntax is you write the word values, in parentheses you specify your various column outputs, and then you enter, and this is what you get. Another nifty thing that I learned fairly recently, despite the fact that I've been working with SQL for years now, is that if you just do table followed by the table name, it's equivalent to doing a select star. Did not know that. So I thought I'd throw this in there, even though it's fairly simple, but really useful if you just need to test small subsets of data and you want to do a limit 5 or something like that. Moving on, join types. So the common join types that everybody's usually familiar with, we have our inner join, which selects multiple rows that are matching on some condition from multiple tables and eliminates any unmatched rows. Then you have your outer joins, which allow you to include unmatched rows within your result set. You have your left join, your right join, your full outer join. Any unmatched rows from a table that doesn't have data show up as nulls. Pretty standard stuff. The one that almost nobody can answer in an interview, however, is what is a cross join? So I figured I would go through that one in a little more detail. So a cross join essentially gives you a Cartesian product of 2 tables, which means that we're joining every single record in table 1 to every single record in table 2. As you can imagine, this is very limited use cases because you don't typically want to blow up your result set that much. But to give an example of how this might work, we do select star from, we have our sample table of stores, which has 2 stores in it, and we have a table products with 2 products in it. I was very creative. We're doing a cross join. Let's say we want to see all possible inventory across all stores. So here we have the combination of all possible products for every single possible store. Moving on, we're going to talk about set operators. Also one that I think a lot of people aren't familiar with if they haven't had to use it. So the one thing that's going to be complex for you guys is remembering this sample data. So put it into your memory because we're going to use it a lot. So we have our customers table, which has the customer name, the city, the postcode, and the country of residence. We also have some suppliers, also across the world, with their country, their postcode, their city, and their revenue. So first, we're going to talk about union versus union all. Union and union all essentially allow you to take two different data sets and concatenate them into one. So this requires that you have the same number of columns selected in each data set, and also that the columns have the same data types. The distinction between union and union all is that union all will give you all records, including duplication, whereas union will give you a distinct list of values. So in this case, I'm doing a select city from customers, unioning all with cities from suppliers. So we get our full list of cities where we have either customers or suppliers, and we can see that Chicago is in there twice because I live in Chicago, and Goose Island Beer is located in Chicago. No coincidence, I swear. Now let's say I want to get rid of the duplicates. I write the same query, but I change my union all to union. Now we get a distinct list of cities where either customers exist or suppliers. Similarly, another set operation that we can perform is accept and intersect. So accept gives you all values in your first result set except the ones that exist in your second result set. Pretty intuitive. Intersect gives you the intersection of both of your data sets. So in this case, the only list of customer cities that existed where also suppliers existed was Chicago, and pretty intuitive. Subqueries. Another thing that if you work with SQL, you've probably had to do many times, or if not yet, then you certainly will. So we have two different kinds of subqueries that we can perform. We have uncorrelated and correlated subqueries. So we're going to start with uncorrelated because they're a little bit simpler. So an uncorrelated subquery essentially calculates a constant result set that can then be referenced within your outer query. It's executed only once. So in our example, I am selecting our suppliers and their city of production, let's call it, where the country is one in which we have customers. So when I do this subselect, we get that the only suppliers we have in the US are Herpetoculture, which if anybody doesn't know, they sell gecko supplies, and Goose Island Beer. They do, I have geckos, what can I say? Now we can do a correlated subquery. The distinction with a correlated subquery is that it can reference different variables from your upper query. So that means it gets re-executed for every single row within your upper query. And oftentimes this means that it can also be rewritten as a join. So in this case, we're going to do a distinct count of customers for each given country where one of these suppliers exists. So in this case, we see that for the two suppliers in the US, they have two potential customers, and our poor winemaker in Madrid and our Exoterra in Canada unfortunately have no customers available to them in their countries. Very sad. Window functions. I'm going through this kind of fast, by the way, just because there's a lot to get through and some of the later stuff gets more complex. If you have questions, you can stop me or ask me towards the end. So, what is a window function? A window function essentially performs an aggregation of some sort or a calculation across a set of your table rows, which is related to your current row, while still maintaining row-level detail in the actual output. So it works kind of like a group by to do the calculation, but then shows that value for every single record that you would have otherwise grouped by. So when might we want to use it? If we need to preserve row-level detail. Syntax, the fun part. So I know, everybody loves this, right? Whenever you go to Postgres documentation, you see this and you go, yeah, I know exactly what that means. So on a more simplistic scale, the basic syntax is going to be that you have your window function name, and it's followed by an over clause, which acts as the window definition and has an optional frame clause within it. The frame clause specifies the set of rows constituting your window frame. If it's not specified, the default is unbounded, range unbounded preceding, and within your frame clause you have a frame start and a frame end. The default for frame end is always the current row unless you specify otherwise. So we're going to go through a little bit of how each of these works. In essence, range unbounded preceding is going to include all rows from the beginning of your partition up to the current row, ordered in the order of your order by. Range between unbounded preceding and unbounded following will give you all rows within your partition, regardless of ordering, essentially. Rows unbounded preceding gives you all rows from the beginning of your partition up to the current row. And between unbounded preceding and current row is essentially the same as unbounded preceding without specification. So let's look at some examples, because that's always the fun part. So if you remember our two tables, we have our suppliers and we have our customers. In this case, let's say I want to see our suppliers' name, country, revenue, and we want to compare their revenue to the average revenue of other suppliers within their country. So I'm going to do average revenue over partition by country. Specifying the partition by clause is the equivalent of a group by in concept. So we see here that we're going to get an average revenue for Canada, which is equivalent to the original revenue of Canada because it's our only supplier. Same goes for Spain. For the US, however, now, we have the average of our two US suppliers. Make sense? Nod. There you go. Now, this is, we obviously, in this example, we use the default framing clause. We didn't specify anything. Now we could. Let's say I want to do a running average as I go through my different suppliers. Now, a range, if I specify a range, it's going to include duplicates as part of the same exact group and evaluate them together. So in my example, I'm going to pull, again, the supplier name, the country, and the revenue. And now we're going to do average revenue over order by country, range unbounded preceding. So in this case, because I'm specifying an order by but no partition by clause, this is going to go across all of my results. So as you can see in the last column, when we're going through our averages, we have a running average until we get to the US. Both of our rows for the US are being calculated in unison and display the same exact value. Now this is different from when we specify rows, because rows will give us a true running average as we go through every single row within our order by, including each of the duplicates. So here you can see we now have herpetoculture has the average of the previous 3, and now Goose Island beer is the average of all 4. Window clauses. So sometimes we may have multiple window functions within our same select statement, and we want them to go over the exact same window frame. We can certainly go through and rewrite our over clause multiple times, but this tends to be redundant, difficult to read, and chances are, what's up? And SQL Server. I was going to say is error prone, because you know, we don't always copy paste effectively. So to alleviate this problem, we can build in a window clause. So in this particular case, we can name our window clause. So in my case, I called it my window, because again, I'm very creative. And we want to partition by the country. Now I simply reference this window clause and this name within my over clause. So now I have my name, my country, my revenue, and now I have my total revenue across all suppliers within my country, and average revenue across all suppliers within my country. So now we can see our sum and our averages are displayed together and are referenced with my window frame or window clause. So aside from using default aggregation functions, so any aggregation function you essentially have, you can turn into a window function. You can use sum, you can use average, count, whatever other calculation you might use. Yeah, that's fair. So Joe is saying to be careful with how you use this for min and max, because, and depending on how you partition your result set, you may get something that you're not intending to, essentially, right? But in addition to using normal aggregate functions, there are also a handful of window-specific functions. And so I'm going to go over 2 of them as an example for you. So one common one that people use is a row number. oftentimes you have some kind of result set, you want to just number all of your rows. Maybe you want to partition it, maybe you don't. So in this particular case, I added a row number. I left it as a default without partitioning. So now we have a row number that basically just goes through and adds a sequential number to every single row in my result set. Rank, another pretty cool one and useful, very tied to percentiles, which I don't go over, but they work the same way. So in this particular case, I'm ranking and I'm ordering by the country descending. So we're ordering our result set by the name of the country. And I'm still displaying my sum and my average across the countries. And so in this case, the thing you have to be careful when you're using rank is that if you have two things which have the same value for your order by, they're going to get the same rank, right? If I haven't specified an additional frame clause. So in this case, our first two suppliers are both ranked number 1. The one after it becomes a 3. So just something to keep in mind. I've seen people try to use rank instead of row number and always found it confusing. So yeah, I agree with you. I yelled at everybody in my current company when I saw this. But nonetheless, I know people do it, so I just want people to be aware. Now, I can also reorder my final result set by simply adding an order by to my overall select statement. Just something to keep in mind. You don't always have to have the rank dictate the order of your output. Common table expressions. Some people love them, some people hate them. I'm somewhere in the middle. So essentially, they're commonly referred to as CTEs. Some people might be familiar with them just knowing them as with clauses. So essentially, the with clause allows you the opportunity to write a subquery that gets stored in memory. It almost acts as a temporary table, and you can reference it later within your query. So this allows you to not actually specify a temp table or a physical table, but do it in memory and not worry about specifying it. But at the same time, you can reference it multiple times within your query. This makes it easier than basic subqueries, which you may have to, A, if you have a lot of nested subqueries, really hard to read. B, if you have multiple subqueries where the same subquery needs to be referenced multiple times, you don't necessarily want to put that entire block of code multiple times within your query. So this really improves readability. The other thing that CTEs allow you to do is have recursion, which really we call it recursion, but really it's iteration. Also something to keep in mind. But we will go over the syntax for that as we go into an example. So first we're going to start with a non-recursive CTE. So in this particular case, hopefully it's not too convoluted to read, we're aliasing my first subquery as C. So we're pulling in the country and the count of distinct customers from our customers table, grouping by country. We're then aliasing a second with clause, essentially, as S, where we have our country and distinct list of suppliers. And then in my final select statement, I am outer joining both of them on country and outputting customer count and supplier count as well as the actual country. So we get something like this. So you can imagine that writing this out in one SQL block would have been a pain in the ass to read. So instead, we did it this way. Recursion. So in this example, we're going to try to list all numbers from 1 to 100. So with a recursive CTE, we specify our CTE name, and then we have to specify our non-recursive parameter first. So in this case, we're just going to start with value 1. And then we're going to union it, or union all, depending on what you're going for, with select n plus 1 from the same CTE name. So we're storing it essentially in memory, and we'll go over this in the next slide, where n is less than 100. And then we're selecting from our CTE name and ordering by n. So this will give us, I didn't post this output because it's literally a list of numbers 1 through 10. My screen isn't that long. So how does this actually work? We start out, we evaluate our non-recursive term, we discard all duplicate rows, assuming that we're using a union rather than a union all. We're then including the remaining rows within the result of the recursive query, as well as in a temporary working table. We then go through and create as long as our temporary working table isn't empty, we go through and iterate until we reach the end. So we're going to go through, we're going to evaluate the recursive term of our query. We're going to substitute the current contents of what's in the working table in for the recursive self-reference. We're then going to discard all duplicate rows again, assuming we're using a union rather than a union all. And we're going to include all of the remaining results within the recursive query output and also place them in an intermediate table. We're then going to replace all of the contents of our working table with the contents of the intermediate table and then empty the intermediate table. And we keep going and going and going until we get to the end. Yes, Sri?
CTEs are also fantastic as optimization fences, by the way. You can force the optimizer to evaluate the CTE outside the context of everything else. So that way, if you want to force the hand of the optimizer, CTE is like your best shot.
There you go. So for anybody who didn't hear that, Sri basically said that CTs are also a great way to force the optimizer to evaluate your subquery outside of the overall subquery.
Shouldn't be doing it a lot, but if sometimes it's dumb. It's great 99.999%.
I don't know that I go that far.
All right, okay, fine.
Depends on your system. Yes, Jim.
It's better than the sum table. Yes, older versions, and I don't know when this changed, and I think it may actually depend somewhat on what you put in the non-recursive CTE, but a non-recursive CTE can also be an optimization fence. So
right. They're all CTEs are optimization fences.
Yeah, all of them.
oh, they are.
Yeah,
Okay.
all of them currently. Yeah, if you use a with clause, it's an optimization variable. We optimize that independently of the rest of the query.
So you need to be very careful about that.
So it can be materialized and it appears multiple times.
That's correct.
As opposed to
Well, and
underlying macro.
that's actually, it's not an explicit requirement. You could actually still optimize them, optimize with them, but right now it's an optimization fence. There's been some discussion about possibly changing that, but I don't know. If we do change it, I think we would change it in a way that would allow you to specify whether you want it to be an optimization fence or not. Because some people really want it to be an optimization fence.
Right. But you do have to be careful because sometimes you're just trying to make the query more readable and all of a sudden performance sucks. And that's why.
Yeah.
So,
I guess essentially the second people labs in Austin and they're the Intersect group. And 15 pages of CTEs before we got to select star from foobar. It's the main clause.
That's rough. So yes, be careful how you use CTs. We're going to go through a recursive example, or an iterative example in this case. So we start out with a new data set. We have a table of parts, which is self-referencing in nature. So we have what is the overall whole that we're trying to build, the part that we're referencing, and how many of those parts are required. So in this case, we can see we're trying to build a car. So we have a car that has some doors, an engine, a wheel, and some wheels and steering wheel. Each of those components then have their own parts. So we can see that the doors all have windows, the engine has a cylinder head, the cylinder head then has some screws, and the wheel also has some screws in it. So what we're going to try to do is figure out how many screws do we need in total to assemble our car. Jim, I saw that.
I try and avoid driving over streets.
I saw that. All right, so we're going to specify our with clause with recursive list. We're going to specify that we want to output the whole, the part, and the count. So we have our non-recursive portion of the query, which is assigning the results to the working table and results table. So we have select whole, part, and count from parts where the whole is equal to the car. So that's our standard that we're starting with. And then for our actual recursive term, we're specifying that we want to join our initial list to parts again where the whole is now equal to the part. So in this case, we're trying to get any component of the car and its components. We could certainly do this through a bunch of subqueries nested, but in this particular case, you don't have to worry how many iterations there are. Whereas if you were doing this through actual subqueries, you have to be aware of how many nested levels in you have to go. So our final product result set, we're going to select the sum of the count from the list where the part is equal to a screw. And I probably didn't, maybe I didn't write out the output for this one. But conceptually, we're going to get, I think it was something like 20-something. Maybe. I think it was 24, yeah. I feel like I had this in here somewhere, but maybe not. Maybe I have it in later. So another nice thing to keep in mind is you can have writable CTEs. So in this particular case, say we want to archive some records, and we want to delete some records off of our parts table and put them into an archive table. So in this case, again, this is not recursive, so we're going to delete from parts where the whole is equal to the car. We're going to return everything. And then we're going to insert the output of our parts archive, CTE, into another table. So conceptually, that makes sense. I'm sure we can all think of a lot of use cases for this. Now we can have this be recursive. So now let's say we're doing a very similar recursion to what we had before, but now let's say I want to create a table that gets us all of our car parts listed in one consecutive list so that now we have the whole as the car and all of its parts specified. So in this case, I'm not deleting anything from the table. I'm doing a simple select. I'm doing the recursion. But now I'm inserting my output into another table. And it's going to look like this. Don't know how many of you remember our initial. But we can see that in this particular case, we have 20 plus 14. So we would have had 34. On a side note. 34. Close enough.
Within an order of magnitude.
Yes, as Jim likes to say, within an order of magnitude. That doesn't fly well in BI, though. They frown upon that. Okay, so lateral joins. It's a fairly new feature within Postgres as of 9.3. A lot of people don't really know how it's used, and a lot of times it can be rewritten through subqueries, which Stephen doesn't like to admit. We had a lengthy conversation about this. So essentially what it allows you to do is within a subquery, in one part of the from clause, reference the columns of earlier items within your from clause. So it's similar in concept to a correlated subquery. So essentially you're allowed to refer to an earlier table, earlier subquery, or refer to a set returning function that was earlier somewhere within your from clause. One thing to keep in mind is that if you're using tables or subqueries, you have to specify the lateral, whereas if you're using a set returning function, it's implicit. So even if you omit it in the back end, it does it through a lateral. So you don't really need to know that. Again, Stephen disagrees with me, but I think if you don't have to specify it, you don't have to know that it's using that functionality. So we're going to give an example. So we're going to create a table for numbers with a generate series. We're going to generate a series of 1 through 10. We're then going to select from that table that we've generated and lateral join it to another series that's using the maximum number from the previous series as the max. So in this particular case, you can see that the two select statements that I have on the bottom, even though one specifies lateral and the other does not, will actually give us the same results because it's a set returning function. So we can see our results on the left-hand side. We have, our max number, which is associated with the right-hand side. Good call. Left to me. Fair enough. Your right-hand side. Hey, maybe you're bad with right and left. I don't know. So on your right-hand side, you can see our result set. It's obviously a lot longer than what I displayed, but frankly, my slides aren't that long. So in essence, it continues on and on. For our full result set, I think there were 55. I don't remember how many. There were a lot. But essentially, we have our generate series, which will generate series up until the number of the max number. So for 1, we only have 1. For 2, we have 1 and 2, and so on and so forth. So using subqueries. On your left-hand side, we have a query which would not work. So in this particular case, we are trying to select some things from 2 subqueries. And we want to select, our first subquery is we're pulling all customers, where the name starts with the letter S, and then we want to join it to all suppliers who exist within the countries of the individuals whose names start with S. So if we try to execute the left-hand side of our SQL statement in Postgres, it will error out telling you that you can't reference the customer country within your subselect. I'm sorry?
Because it doesn't exist yet.
Yeah. So it doesn't exist yet is the reason that it can't seem to calculate it. If, however, you augment your join statement and specify join lateral, now all of a sudden your results execute. It's like magic.
The levels are created in parallel all at once.
Right, so
That's why you can go back and forth.
so what Joe said is that in this case, they're created in parallel at the same time, which is why you're able to reference back and forth. And so the lateral essentially tells the optimizer that you have to do this. So this would then be our output. We're going to get myself and Steven, who both have suppliers available within our country of residence. Now, what's up?
I'm sorry. Yeah, for beer and lizards.
Beer and lizards, that's the way to go. It's a good life.
A wonderful evening while watching television.
Exactly. Now, one thing to keep in mind is I could have accomplished the same result using a correlated subquery within a join criteria. So at my company, we like to do this. It makes me sad, but we like to do this nonetheless. So we kept our first subselect the same. And then rather than doing a subselect for our suppliers table, we're joining our suppliers table where the ID then matches our correlated subquery. So this will produce the same exact results, but as you can see, it's much more difficult to read, and it gets much more complicated, right? Imagine you have 15 or 20 of these kinds of joins, which you shouldn't do to begin with. But in concept, oh, but we do. That's the beauty of it. We do. But the idea is you can certainly do this, but it might end up being slower depending on the other components within your query because it's not going to be optimized as well by the optimizer. And B, even just from a human readability perspective, this is much more difficult to read and much more inconvenient, right? So if you can use lateral and it's available to you, why not? And that's it. I thought you guys would ask more questions throughout. Or maybe I thought I'd talk slower. So do you guys have questions on what we covered so far? Really, Joe?
It's going back to slide number 1.
Yes.
I always think of order by as being part of a recursion, because that's the way we defined it in ANSI, not part of a basic query. The order
That's
by
fair.
doesn't make sense unless you're going to go through. And officially, that's how we defined it. Now, because in the early days, when we were still the database and presentation layer were kind of, we hadn't separated out to a tiered architecture yet. We didn't know about this architecture stuff. And, why does Sybase have things like convert to format dates?
Right.
Money data type, put in commas and punctuation. Oh, because COBOL programmers expected that with their picture clauses.
Makes sense.
And we wrote a lot of our early code to match. Yeah, no, hey, don't knock COBOL, it'll never die. It's forever will outlive you. It's getting to be the COBOL of database, God help us. So I can always, as I'm dying, I can still write select from where, and it'll work.
That's true.
But, no,
I'm having that put on my desk. Actually, I suppose delete would be more.
delete from star.
Yeah.
I hope not. That could get messy.
Do you have a organ donor tattoo on your chest yet, or just the DIA, or do not resuscitate? I'm the only guy probably here with a penicillin allergy O positive on his arm when he was young, and is looking for my DNR and organ donor tattoo on my 75th birthday.
That's a little morbid, Joe.
Person, what do you have to chronically wears black suits? But no, essentially were sequential,
Right.
having evolved from punch cards and tapes and whatnot. And I don't really consider it part of the basic.
Well, mine was more so from a
No,
user.
I know
Yeah.
you're doing an interview, yeah.
Yeah. So for us, we say, oh, you have SQL on your resume. What do you know? I know select star from table where something order by column 1. That's usually the response I
And
get.
I can spell SQL.
Yeah.
And I didn't know that it's supposed to be pronounced SQL.
Exactly.
We spent 3 days on the committee on that.
Did you really?
Yeah.
That sounds
no,
rough.
It's the X-Base people. Does anybody remember X-Base? No. But they came to their name in like 8 hours after meeting and getting drinks. It took us 3 days to decide that it's SQL.
Well, it took 3 seconds to come up with the name PostgreSQL, and we've regretted it ever since.
I can't comment on that. I wasn't there. Yeah.
On the example of lateral versus the correlated subquery, is there performance benefit using lateral?
Does the lateral optimize?
I think it depends. So I've gotten some mixed responses from people. Per Magnus, on the average, lateral would probably be optimized better. But I don't think he's willing to guarantee that, nor am I.
Well, I think that
Well, the correlated, if it's a small, if you know it's small, correlated will probably be a little bit better, right? But if it's big, lateral will be better?
Well, I thought I understood you to say that it behind the scenes is doing lateral anyway.
No, that's on set returning functions.
Oh, okay.
Yeah.
Set returning function is that way. When it comes to lateral versus the correlated subquery, in both cases, you're going to end up doing a nested loop. That's how lateral is going to end up working. And so the actual performance difference is probably not going to be very much because you're going to be doing a nested loop in both cases.
eventually, lateral says essentially do these two guys at the same time so they can coexist and reference each other, like coroutines,
Right.
back in procedural days. If my hardware and my architecture changes, and I can in parallel materialize the two sides of the lateral, eventually the lateral should be significantly faster than having to materialize him and then go down with the subqueries. And
Yeah, but that's not how it's implemented.
oh yeah, no.
We'll find out once we have parallel queries.
Yeah. No, super parallel queries, or every row of the table has a little demon, like Maxwell's demon, waiting to see if it should pass it on to the
So
next level.
I don't know if the optimizer understands that particular construct. I'm 98% certain though that if you do that the other way, where you say where, instead of doing it with a join, you say where s.id in, and then the subselect, the optimizer does know how to rewrite that to a simple join.
Yes.
And when it rewrites that to a join, all the join possibilities are available.
No.
Yeah, which is better. The other thing though is that, I mean, rather than doing an in, you probably want to do an exists. Which
It depends on what you
It depends.
Well, that can make a bigger difference because the in clause does end up actually materializing the whole stupid thing, or can't, depending on if it can't figure out to turn it into a join. You end up doing that, which
The
is
other one
sucking.
with the in predicate, nobody remembers, is that some of the elements in the in list don't have to be scalars. They can be scalar subquery expressions. And you can write some in stuff that is an absolute bitch to optimize.
Yes, yeah.
Been there, done that.
Mother would be so ashamed.
Yeah.
Does this change if you return a set function then, or is it still equivalent?
It's totally different because an SRF, can we push SQL SRFs? That's a fast. So set returning functions they're more than an optimization fence, like they're a full-blown, totally different method of execution. You basically, after calling the function and iterate through that function, to then drive those tuples into the rest of the query plan.
Oh, you guys have an SQL SRF, a straight language SQL SRF in the inline?
Yeah, I can't remember if we can do that.
I think so, but I'm not
exception to that, it might be if you write an SRF in the SQL language function. There's things that we can do with SQL language functions where we go, oh, that's just SQL.
Yeah, we would pull it into the actual query itself and optimize it with the overall query.
So I just write a store procedure and return to set, you can do that.
If you write a
Only if it's written as a SQL store.
that was written in SQL language, not
ELPGS.
right.
Yeah.
Yeah, exactly. It's not,
All right, well,
Basic rule of thumb, an SRF is generally not going to be as fast as the raw SQL.
right, that's true. Can be very handy.
that can squish someone's results easier down, so overall it can be better.
Sometimes it's when you get to this level of query optimization, seriously, you have to try because there's so many different things that can happen. Your best bet is what I personally always do. I write for the clear code first, and if the clear code doesn't give me the performance I need, then I start going, okay, how do we funnel up the code to
Any other questions?
Yeah. How dumb are the interviewees these days?
They're not necessarily dumb. They just often don't have any database experience, right? Especially if we're interviewing kids straight out of school, right? They're like, oh yeah, I had a database class 2 years ago. There were tables there, and we used, what do they use? Like MS Access or something like that. And I'm just like, all right, that's going to be really useful here. Go learn some SQL. But no, they're not dumb. They just
Inexperienced.
exactly.
Nice word for ignorance.
Exactly.
How many are willfully ignorant or happen to bring in some other data model?
I mean, a lot.
I keep seeing people rewriting 1950s, 1960s magnetic tape file systems in SQL.
Yeah.
I'll go ahead and say it. The SQL Server forums have the dumbest animals on earth. They were probably forced into learning SQL from VB with no training, no nothing, and they don't know the difference between a row, a column, a field. They don't know the basic terms, and I'm going to go ahead and materialize something because that's how I would have done it with a scratch tape in 1960,
Yeah.
as opposed to putting it in a derived table in the middle of my query. And I write sequential, I write local variables. What's one rule when you're doing a declarative language? No local variables, no loops, no if-then else's, right? They don't know how to write the code at all, so they mimic.
Yeah, but I mean,
all they've never seen.
yeah, well, because they're coming from a different field, right? If they were doing a computer science major, they maybe had a class that showed them some basic database work, which really they probably had to associate using C or Python or something else, right? And so a lot of these guys, they will pull things in through like R or SAS, and they'll work with it there, right? And they don't know how to model that data. They don't know how to work with it directly. So,
I don't
yeah.
think that's limited to SQL Server either.
No,
To me, it's an issue of,
It's just, no, it's everywhere.
right, because procedural programmers think differently. They don't understand set theory. And that's, if you don't understand set theory, this stuff just not.
Now, one of my tells is if they see a table with a singular noun for a name, you're doing record processing. When you say employee as opposed to personnel, the higher level abstract set concept personnel, oh, I'm processing employee, not employees even.
We'll have to agree to disagree on that one.
All right. What was your question?
You have
Oh, sorry.
an example in the CTEs that are both writable, and then you had the recursive CTEs and said recursive writable CTE, but the CTE itself was not a write in the recursive example. Is there actually an example that you've seen or that you can imagine where you actually want a recursive CTE that is an update or a delete or an insert?
You can.
You can?
I don't think you can do that. Yeah.
I'm not even sure what that would why you would do that.
It doesn't really make any sense, I don't think. I mean, what would it, yeah.
That's what I wasn't sure. It was under the same slide title, and I was.
For example, if it was an insert in the recursive term, it would never end, right?
It could be really
Yeah, if it's a delete returning, I mean, I just don't think it would. No.
Maybe an update?
I'm not sure.
Actually, there is like a second quadrant doc from 2012 sometime where they actually use a second CTE in conjunction with the first one, which is writable, to debug the execution of the first CTE. So it's not like it's
That
not
one's actually cute. I like that.
yeah, it's
kinda cool.
really nice because that's what I did. It's really annoying when you're like traversing subgraphs and stuff and you don't know where you're stuck, right? So it's not perfect, but like you can use it for tricks like that. So.
Yeah. Well, and I saw. I think it was Josh Burgess had an example of basically mimicking a not concurrency safe absurd with
Yes,
CTEs, which I thought was
Oh,
kind
I
of
saw something like that.
I've seen that about 10 times.
I probably don't have it anymore, but from the standards committee, Phil Shaw put in the recursive CTE proposal. I think it was Phil Shaw. Somebody from IT, I think, still working there. And the full version of the original recursive CTE included width first, depth first. It had like 42 clauses for determining exactly how this declarative language construct would be implemented procedurally.
At some point, just shove it in the sort of
And that's-
procedure and be done with
Yeah,
it.
and no, at that point, that's when we went to the just simple recursive with a fixed point and iteration. The original proposal for it was a total nightmare that came out of the Santa Teresa boys smoking pot.
On that note,
Unimplementable, baroque, and at that point, yeah, if you're gonna do this, fuck it. Get a cursor and do it like a mag tape file. Be done with it.
Megan.
I'm gonna put your slides up on
This
the
is why
wiki,
it
so
died.
I'm gonna need to refer back to, this helped me understand window functions much better, and I wanna be able to refer back to this.
Sure.
Figure it out.
Yeah, I can do that.
This will make up on the Twitter.
I don't have Twitter, but I will get the link from one of you guys.
I'll tweet you the link.
Thanks, Jim. Helpful. Any other questions?
There's a foreign data right.
Don't get me started.
No? All right. Thank you, guys.